Okay, hello everybody. Well, it's a lovely Monday morning here in beautiful Vienna, and we'd like to welcome everyone in the audience and everyone online to today's seminar. Today we've got a special treat. It's a 2-for-1 deal. Usually we only have one speaker. Today we've got two, so you get double your money today. And this is part of what Philip and I, when we were organizing this the seminar series, what we were interested in doing was to have a sort of a special series towards the end on the very earliest humans in Europe. So this month and next month are going to be a part of a theme looking at early humans, and next month we're having Nick Ashton from the British Museum who's going to be here to give us a talk. But today, as I say, we're very pleased to have two really interesting speakers who've been working together on a lot of really interesting archaeology recently. The first is Professor Roman Garba. Roman's got a really interesting backstory. He studied in Poland, Leicester, Naples, and he started a professional career in project management, consultancy, and counseling in Europe and the Middle East. Since 2012, however, he's been working on the application and development of cosmogenic nuclide dating applied to archaeology. We're going to hear more about that today, including methods measuring radionuclides such as beryllium-10, aluminium-26, and my favorite isotope, radiocarbon. He also directs the Arduk project in Oman, and he's affiliated with two institutes, the Czech Academy of Sciences and the Nuclear Physics Institute and the Institute of Archaeology in Prague. His co-presenter today, Vitalii Usik, is a member of the National Academy of Sciences of Ukraine and works at the Institute of Archaeology, the Archaeological Museum in Kyiv. He has many years of experience working in Middle and Upper Paleolithic archaeology, including extensive field work right across several continents, including in Oman, Ukraine, and his work at the Dniester River Valley with colleagues here such as Philip Nigst and others in Gravettian, Epigravettian, all the way up to much more recent archaeology. And so it's a real pleasure to have you guys here today. So welcome to HEAS, welcome to this talk. And it gives me a great pleasure to hand over to Vitalii Usik, who's going to start this presentation.
Okay. My part of presentation about new discoveries, new age of lowest level of Korolevo site. I will begin from presentation of archaeological part of this site, and the site located in the western part of Ukraine. A second here. Practically, we have that range of Carpathian Mountains, and the site itself located on the left bank of Tisa River, on the edge of so-called HEAS gates. You can see on the edge of HEAS gates. You can see here, this is Tisa came through the volcanic ridge, the Gorlat-Gutinsky volcanic ridge. Practically, it is western northern part of a volcanic or ash volcanic region that came from Romania. And from this point, that area wide open, Tisa came to Transcarpathian Valley or Pannonian Plateau. It's very age of this. And why people came here? It's not just because elevation. Here we have volcano, raw material. We have for this time work in spring, and people lived on the elevation 100-120 meters on this volcanic mountain. Now you can see the picture before it was destroyed by quarry. It's more or less original position or face of the mountain where site located. And of course, when you see from this elevation, you can see valley, you can see animals, and you can hunt. And but two main sources: it's raw material, and it is second, it is water that is not from Tisa. Here there is, and on all maps even there is springs that between two elevation divided on this mountain we have 3 locations I will show later. And here on this map, we can see this point. It is point of local raw material, volcanics, we call andesite. I will tell a little later. And from the other side of River Tisa, it is source of local obsidian, obsidian number 3, in now recognized as there is Slovakian, Hungarian, and from the other side of this valley, we have source of obsidian, but people here used mainly local raw material andesite. This is a view from Gostriverh to the valley and to the side. So there are three kind of sites: Korolevo 1 Gostriverh, Korolevo 1 Bever divided by tributary, and Korolevo 2, it is 20 meters terrace with early Upper Palaeolithic, Gravettian, and with long sequence. Now we know it is long sequence up to 9 meters of quaternary sediments. Here again, that we can see position of Korolevo 1, Korolevo 1 Gostriverh, Korolevo Bever, and Korolevo 2. We don't touch now Korolevo 2. We just concentrated mainly on Gostriverh, and difference between Bever and Gostriverh, it is a difference in the thickness of quaternary sediments. On Korolevo 1 Bever, quaternary sediments with archaeological levels gained from 5 meters to 2 meters, so it is very compressed. Instead of Gostriverh, we have long sequence between 14-12 meters here, and main stratigraphic position and main in situ material found exactly here. And here it was made for the long time many different investigations of in sondages, excavation areas, profiles, geologists, Paul Ezerts, before it was Adamenko, many years worked. So it is main stratigraphic part with in situ archaeological levels. So it is most important, and here it was obtained many times. Motoyama Brune's inversion many times, at least 3 times it was made investigation, and we have this result. So it is how it was investigated when in 74 site was discovered by Vladislav Gladilin. The age of quarry was in the middle. Here it is. Here you can see the position of excavation areas and sondages, and it was made more than 50 sondages through the 2 areas and many excavation areas on Bever and on Gostriverh with different sequence, different depths, different archaeological levels, but for us, main part, it is excavation area 13, excavation area 10, sondage 26, profile of Paul Ezerts, profile of Polish team, and you can see on all slides this part of excavation 13, upper part excavated, and it came from surface down around 8-9 meters. And excavation 13, where it was found in situ small collection of level 7, which was dated. Here you can see stratigraphic sequence made of Adamenko on the base of excavation of sondage 26 and 18 and excavation 13 here in 98. It was profile made by Paul Ezerts, and here it's explanation of that sequence in that time. And here the investigation of profile was made by Polish team, and in investigation in the time of Adamenko and Paul Ezerts and Polish team, it was obtained that boundary between Motoyama Brune's inversion. So it is 3 times it was proved in this area. And material which was found lowest level was under this Motoyama Brune's inversion. and it was kind of dated, the site dated older than 7,800, around 1 million, but we didn't know how it is old. Here we have, you can see on profile main archaeological levels was found on Ghost River. It is level 7, level 6, 5A. There are traces here, and we have long archaeological sequence in this area with different cultures, beginning from Lower Paleolithic with choppers, Olduvai, Lower Paleolithic level 6, and after that bifacial points, level 5. It is located under Aemean soil, and different variants of Middle Paleolithic in MIS5A, MIS4, MIS3, which is we have sequence classical centripetal levola. We have levola points industry with Tabun B type, Mikakian, Charantian, and early UP in the bottom of upper soil. So it is presentation what we have on this site, not only Lower Paleolithic. We have long sequence in different areas. We have in one place we have level 3 all around to Ghost River and Beaver, but other it's unique, like level 2B we have only in one excavation area, level 1A only in one excavation area, and for example level 7 it's in situ found only in excavation area 13, and maybe now we investigate maybe excavation area 10, which is related. The main raw material, I told that used main raw material, archaeological name andesite, geological name now it is hyalodacite, but we are not sure because we have new investigation and maybe it's hyala andesite. So it's unique raw material. It is looks like, in original it has a black color, and after that through the time it is weathered, and it looks like for the first time like sporia, like pemus, but this whole vesicular appeared through the age of weathering, not so it is different physical chemical process. So what is interesting, if you look on flint material, sometimes we have patinated, not patinated, and patinated, not patinated doesn't have that sequence. On andesite, there is gradation from the less patinated on the top or not patinated fresh to down through the age with more destroyed surface, and there are variation in each archaeological level. We have variation of patina from gray bluish to white, and white usually more patinated, and it was made some mistakes through the determination of cultural levels, because level 7, for example, was divided on 7 and 8, level 6, 5A, 5B, 5C on the base of this raw material. But now we come back to investigate not just raw material. We took samples from in situ excavation, one collection, one part of collection. We reduce surface material, and with new investigation, we have little more precise information about process of patinization through the time. And for example, I can send the level 3 classical level centripetal, which is MIS5A dated, sometimes have more destroyed surface than level 5, which is belong to isotopic stage 6. So there are some variation. Now we can read it and we can correct. And from the point of determination of surface destruction and level and age of artifacts, we can determine even work with surface material, which is not really surface. It came from quarry, from cultural levels when quarry was excavated by bulldozers. The material came down, so practically we collected material from cultural levels. And we can recognize difference, and this difference consistent. We have, for example, on some artifacts, this surface, which is belong to age of level 5A surface. We have reduced surface that belong to level 5H, and we have natural cortex. So through the reutilizations, through analysis of reutilized pieces, we can play with age of this older, younger material, and it's really consistent. The most difficult for determination, it's level 7 because it's more than 1 million. Sometimes not easy to work. If you don't know this raw material, sometimes it looks like natural. But we can divide natural and split it easy, again, playing with surface and natural cortex and ventral dorsal surface. And we can see this material. If you look on this and fill these holes with plastic, you will get a real surface of what it looks like when it was splitted. But now we have this, and it's easy really to kind of to make mistakes and put it in natural, but we can divide this. So here, after publishing, after publishing of data from excavation area 13, we come back to investigate area around, and we came through all slides. So it's absolutely new information. So we came to investigate excavation area 10. It was excavated in 78, and at first time it was marked there is material culture level 7 in situ, and it was a conference. Many famous archaeologists came to Korolevo. And Dokladnikov, even the famous Russian Siberian archaeologist, offered to organize long-term expedition. And he marked that is the excavation methods is great, and they visited this part and they saw that profiles, and so he was excited about that. But we was excited when we found we came through all slides, investigate, and try to recognize some slide with original excavation. And here you can see in the middle of excavation 13, in 78, it was huge excavation with some artifacts, and we can see position of level 7 here, some pebbles. We have to reinvestigate these artifacts, not artifacts, but anyway, that alluvium, it is much lower, and we have in horizontal position some artifacts and some pieces. And about investigation, here, excavation area 26, it looks like down pyramid. And here in the bottom, on the top, it was 8 meters excavation, and finished on the bottom 1.51 meter. So it was impossible to find any artifact there. So because it's open air site, and sometimes you have on huge area 1-2 pieces, sometimes concentration, sometimes. So it is not easy site. But anyway, in this excavation area, it was made long profile from the bottom to the top, and there are small tags with numbers. It's 96 samples for palynology. So it was really investigated with geologists, palynologists, paleomagnetic, and so one of the major part of investigation Korolevo, it was geological investigation of stratigraphy, sequence, and so on. Here you can see what was found at excavation area 13. It's small collection. It is 33 artifacts with pebbles not included because we were strong, very strong. Just look on what is really 100% artifact. And here we can see small collection, but chopper core made on quartzite, core-made unidirectional multi-platform reduction, which is usual for this Aldebaran industry made on silicified sandstone, small bifacial tool, very strange. Camberva flake, not easy to read, but we can recognize this. Some flakes, again, with negative, sometimes very strange, but again, difference between reduced part and ventral, dorsal, and natural cortex, we can see. Some most questionable, it is polyhedrons like this, but we have these polyhedrons usually goes together, spheroids together with lower Palaeolithic Aldebaran industries. We don't know yet here it is how it was reduced, but it's question for experiment. It's we not exclude it can be used some fire. It's too early, but it's possible to reduce it. At least it's not natural because we have cortex, reduced its surface. We just don't know how it was reduced in that time. People were smart. And there are some flakes, some coarse, and again, we have difference in surface between reduced part and natural cortex, because natural pieces do not have this division. And as rule in collections we have and level, for example, in level 6, we have a lot of chunks, and usually chunks, fragments. In each archaeological collection, we have chunks and fragments. We can explain, or sometimes not, what kind of reduction, how it is produced. And it's a question for investigation, next investigation of level 6, because here we are talking only about excavation area, about excavation area for dating 13 and level 6, level 7. Level 6, we have that artifacts in many areas, but in situ, in 13, in 10, and 26, 18 zondages, and reduction, primary flaking. We have multi-platform cores, unidirectional cores, some Camberva cores, some cores even looks like UP, but the age of this around 500,000. But we have this, and andesite surface supports it. By the way, that pieces made not on andesite, on quartzite, or flint, or silicified stone, beautiful condition, you will, if you will find on the surface, you will never put in lower Palaeolithic, for example. It will be middle Palaeolithic, upper Palaeolithic, or whatever. But it's show pictures and type of reduction. Level 6, again, between tools, there are very weathered, not easy to read like this denticulate, and we have pieces made on other raw material, which fine made, and again, it's you can put in middle Palaeolithic, not in lower Palaeolithic, not in Aldebaran. At the same time, we have pieces made on exported raw material and the same type made on andesite. So if you put two pieces together, we can recognize. And again, it came from in situ collections. Reduction primary flaking looks like very difficult, but secondary flaking and tools very developed. We have level 5A in sequence with bifacial lip-shaped points made on exported raw material and on andesite, sometimes ugly with many holes. But it is this industry is unique. We don't know for this age in Europe this kind of bifacial point production. For example, this piece is possible to put just in Neolithic or Neolithic age if you will find on surface, but it was found in situ, and I was participating at that time, so no question, it goes together with this andesite and quartzite pieces, so it is the same level, the same industry. Next, I will go quickly. Level 5, I told level 5 patina of andesite, little less than level 3. The main question of level 5 on and it's dated to MIS 6. The main question of level 5, usually we have a lot of hundreds, I don't know, 500, 300,000 of the pieces level 5 found on Baver, and the main problem of this, it is contaminated of heavy duty workshops. Like they produce, took big blocks, 2-3 meters, 1 meter, made stationary cores, produce flakes, and from flakes made cores like Kambava, parallel, different. Compared to Baver and Gostriverk, we have not much in situ material, and potentially, this blade core, potentially it's more interesting now, Baver anyway now destroyed, to investigate, to get in situ collection of the site, not contaminated by workshop, influence. One of the interesting part of level 5, it's blade production, and we have some end scrapers, and we have burins and blades, burins. Here we have only these pictures, but they are made on quartz. It looks like Near Eastern, company came from Kizim Cave. It's a part of collection, and Gostriverk, it's a part where it's possible to find in situ this material together with blade production. Level 3, it is classical centripetal. You can put these pictures in any that book for Palaeolithic. There are refittings, and it's we have this material and Gostriverk and on Baver, and it's all the time we have in the same position of the top of Amiens soil, and so no question here. Next, from Gostriverk only, we have industry with level points, which is similar to Tabun B type, is short, broad base. There are some difference, but practically it's analog of Near Eastern Tabun B type of level point production, convergent, unidirectional, short, broad based. And these tools, and there is collection, many refittings. So no question. Level 2A, it's Mikakian with many side scraper, bifacial pieces, thinning, and so on. Level 2 in Korolevo belong to Charantien type Kina with different reduction strategies, but we don't have practically bifacial tools. Limaces, there are limaces, side scrapers, and bifacial thinning part of on tools. It's compared to Mikakian, it's they use tools as cores to produce Kambava flakes, and there are refittings that prove this. Level 1A is EUP, what we have on Gostriverk only, and small collection on Baver. It's EUP, it looks like regnation without regnation. So it is crested blade preparation, core tablets, soft hammer, and scrapers, but no diffuse and no microblade production. And on the top of different areas of Baver and Gostriverk, at the end we have not patinated or light patinated andesite tools. Before it was determined like denticulate mysterium, but it's usually found in Galacine sediments together with pottery, with polished axes. So it is there are on many places spots of artifacts or sites that belong between Neolithic and Bronze Age. It's not really investigated. We have that material. It's open for investigation. And question of the main question of dates of why we choose only Gostriverk, because here you can see again nearly made that profile slides from old time. This is from 76. On Baver, the main problem, quaternary sequence very compressed. If we have very good level soil 1, that is MIS 3, loss in between soil, next soil, it's Amiens soil, and maybe some loss in the bottom. After that, everything compressed, and here, for example, we have very good collection of level 5, which is practically on the top of Pliocene sediments mixed with 6 and 7. So On all of this Beaver excavation, mainly it is related to kind of pits or depressions, and material came down, and we don't have this sequence to date or to work with level 7, and level 7 unfortunately mixed with level 6. And now come back, we can play with in some material to divide only by undesired surface 6 and 7, again, very carefully. But this is a question of a Beaver, why we don't have here really proved and 100% in situ material to date. And so now it is other part about how it is dated, why we come back to excavation area 13.
Good morning, everyone. We would like to thank organizers to inviting us to Vienna and to have the opportunity to have to say something about the beautiful site of Korolevo. My second part will be about the recent investigations and using of the cosmogenic nuclides or applied nuclear physics to serve to answer the archaeological questions. This part is called Cosmic Clock for Human History. As everyone who is doing something in relationship with human evolution has his own version of the map of the world with dispersal, human dispersals. Everyone has his favorite arrows and points. This is kind of my version, which I'm using. Here you can see the major sites which are older than 1 million years and which are primarily absolutely dated, because we are focusing, or I'm primarily focused on absolute dating, and they are older than 1 million years. In red, you can see that the sites which were dated by using terrestrial cosmogenic nuclides. So this dating method, it's quite commonly used in dating of the very early hominin sites which are older than 1 million. And there is a lot of publications related to this. There are also some other sites which are interesting and have potential, but are still not dated. And as you can see, I'm also kind of favoring also southern dispersal route, but of course both routes, they were available, but still we do not have any firm robust dating of any archaeological site in Arabia. This needs to be, this is waiting for publication or for discovery. Here you can see the consolidated, the first unpublished, still consolidated view of the chronostratigraphic model of Korolevo. We put together all the data on all the layers from all sites. Also the dating, so far it was done TL, thermoluminescence, but for Korolevo 2, we did also the C14. And this will be published in a book which Vitalii is preparing. And the main focus was at layer 7, the oldest, because it was not properly dated. So we wanted to use the cosmogenic nuclides, but also layer 6 is kind of shaky. The upper layers, they have pretty good thermoluminescence dating, but of course it needs complete revision, because all this dating were done way before in 70s, 80s. Only these younger layers from Korolevo 2, they were dated using AMS with the C14. A few words about the terrestrial cosmogenic nuclides. They are coming from the deep space. They are coming from outside of our solar systems. They are this is primary cosmic rays, which are produced in explosions of supernovas outside of the solar system. So they are showering our Earth day and night, and they are making a reaction with atmosphere and nuclear reactions and producing secondary cosmic ray particles, neutrons, protons, and muons. And this shower, it's dropping to the Earth surface, and with a reaction called spallation, their cosmogenic nuclides are produced in surface rocks in target elements like oxygen, silica, calcium, manganese, potassium. This kind of intensity of this cosmic ray flux depends on where you are. Mainly depends on magnetic field of the Earth, which is kind of main shield, which protects our planet from the external cosmic rays. So it heavily depends on latitude and also elevation, and needs to be considered in the calculations. We have the most commonly utilized cosmogenic nuclides are radionuclides, beryllium-10, aluminum-26, chlorine-36, but also carbon-14, which is obviously very commonly used in archaeology, but the carbon-14 mainly is used 99.9% in like as meteoric, which comes from the atmosphere and in organic material. It's little less known that also there is a C14 produced in minerals, in quartz, which we called in situ C14, and this is kind of very specialized. Only few labs can do it. Then cosmogenic nuclides also to the family of cosmogenic nuclides belongs the stable noble gases, which they don't decay, helium-3 and neon-21. Each nuclide has a different half-life, and based on the half-life and where it's produced, you can process the samples, or you can date different type of samples with different lithology. The most commonly used are beryllium-10 and aluminum-26 from the quartz grains, and so the target lithology is vein quartz, quartzite, sandstone. But we have also chlorine-36, which can be used to date limestone, for example. The cosmogenic nuclides are primarily used in geology, in geoscience. They can answer the broad questions of a broad spectrum of geomorphological problems, like history of glaciation, landslides, landscape formations, catchment, wide denudation rates, shorelines, chronologies, the age of the shorelines, landslides, but also are used in archaeology. And there are several types of dating. You have the exposure age dating, and then you have boreal age dating. Exposure age dating I will skip. I will focus on boreal dating, which we used in our case for Korolevo. And how does it work? In very simple way. It is like you have the shower of the cosmic rays, and on a surface rocks, it is produced these nuclides, which it's like charging of the battery of your phone. It's charging. It has a kind of limit. It has kind of an equilibrium, and it's increasing, but it's charging in in a known ratio between beryllium-10 and aluminum-26. When you bury these rocks or you shield them, for example, you move them into the cave by a hominin moving into the cave, you obstruct from the cosmic rays, and these nuclides start to decay, and the beryllium has half-life 1.4 million years, and aluminum is 700,000. So this ratio starts changing because the aluminum decays faster than beryllium. And then we measure this concentration after very time and labor-intensive processing. We measure on AMS, on accelerated mass spectrometry machine, the concentration of these nuclides, and then we calculate, based on this ratio, we calculate the age, how long the rock was buried. This is very much simplified way to explain how does it work. And back to our case, so we processed the samples which they were stored in Archaeological Museum in Kiev from the Transcarpathia Palaeolithic expedition in 1985. They were the pebbles from the layer 7, the oldest, lowest layer. And we were lucky because this excavation 13 was done properly, and every pebble and every artifact had labels with squares, with depth, so we had evidence and kind of documentation. The pebbles were quite mixed. The material was vein quartz, quartzite, but mainly sandstone. And sandstone was not clean, of course. It was very dirty material, so not good for sample preparation. And in geologists, they have advantage that they can pick up the nicest, cleanest quartz samples from the field. But here in archaeological cases, in archaeology, we just have samples which were given, and you have no too much choice, so you have to somehow kind of it's challenging. It's an additional level of challenge that the sample are not the ideal. They are really extremely contaminated or dirty. And this is the very simplified procedure, sampling processing life cycle. It has around 50 steps. It starts with a crushing, washing, sieving. This was done in Czech Geological Survey. Then checking of the mineralogical composition by XRD, magnetic separation on France magnetic separator. Then this is extra step we did on our research nuclear reactor in Nuclear Physics Institute. We did via instrumental neutron activation analysis, elementary composition to know which kind of, how much different elements do we have. And then on the right upper side, you see the samples. They are not, usually the quartz is purely nice, like a kind of white sugar type of the material, and here you see it's very dark, it's very kind of a lot of impurities inside. So was then this chemical kind of preparation and purification, which was done in Rosendorf, in Dresden, in HZDR. It's a very, very long process to clean it up. Then it was the beryllium aluminum separation, the spiking with a carrier, then ICP-MS measurements of the aluminum amount of aluminum needed for later calculations, then it conversion of the into the oxide, and then finally measurements on the AMS machine in HZDR. It was done. Plus we did mass scans as an extra to see any impurities and what elements do we have there. And these are the results. Actually, the data are the most important, what you measured, but that is not enough. This is another big step, is the a real calculation of the age, which is really sophisticated, demanding work, which was led by Matt Knudsen from Aarhus and John Janssen from Geophysical Institute. We used two methods. First was the kind of classical isochron burial dating, which is commonly used, but we tried to use the quite recent new method which uses the latest advances of mathematical modeling, and method was called or is called PPNI, particle pathway inversion of nuclide inventories, which uses Monte Carlo simulations, and it's can achieve much can achieve smaller uncertainty because it also calculates the different sources from different sources. The samples are coming with different production rates, and also can account also the different deposit, different accumulation, sediment accumulation histories. And the results came out we didn't expect. We knew that it will be around 1 million or more than 1 million. But when the first results came, we were surprised that, and then we used both methods. Both methods came with the same results. The PP needs more advanced method, so delivered more tight uncertainty range. And the outcome was 1.42 plus minus 0.1 million years, 1 sigma uncertainty, which translates to roughly 1.5 to 1.3 million years old. So this PPN method was first time used in archaeology. It's used in primarily in geological kind of glaciation histories. So it's very powerful and good method. And then in our paper, it was not much visible because the main output was the dating of the Korolevo site. But what we did also kind of superimposition with the paleoclimate data. So we incorporate the climate model to narrow down the hominin dispersal pulses. So how we did it, because in Korolevo we have very good and very detailed record of pollen record from every layer. The Natasha Gerasemenko was leading the analysis, and we know even trees, which plants they were in each layer. So we knew that the layer from the pollen analysis of layer 7 that the sediments indicate or pollen indicate warm conditions, which suggest interglacial periods. So oak, elm, these kind of trees. And then we took the data from the server from Korea. It was published in Nature by Axel Timmerman in 2022. I recommend you can go, everyone can come to see, to access the server, and then you can put coordinates of your site. You can put the range up to 2 million back, and then you can select if you want Homo erectus, Neanderthal, Sapiens, and you just get the outcome kind of hominin habitat suitability index, how good the climatic conditions were good for humans. And then so we did it for our age range, which we calculated, and then we identified, because we knew from the pollen data that was the warm climate. So we identified the 3 peaks, like MIS 47, 45, 43. Actually, they were the warmest the interglacial periods from this Middle Pleistocene range, and we were able to narrow down to like 10,000 years kind of births or time slots with a probable hominin arrival, which is a kind of interesting approach to even narrow down more the expected age. And then also we came up in our paper with a hypothesis that it very most likely they came through Danube migration corridor, either from the southeast, from Anatolia, or from northern Black Sea to the Korolevo. But for sure they extinct or they retreat, but very likely they extinct. It was just one of pulse. Here you can see we publish it in Nature, and this our study. And this study was quite, or still it is quite significant, because it fills the gap between the Manisi, which we know it's 1.8 million on the east side, and Atapuerca, which is 1.4 to 1.1 million on west. And the Korolevo is somehow in between. It was also the first, or the evidence of the most northern evidence of the Homo erectus. We think that it's Homo erectus. We do not have any bones, any fossils in Korolevo, unfortunately, but we assume that it was very likely Homo erectus, because at that time no one else potentially could be. And it's still potentially the oldest archaeological site with lithic artifacts. Very recent this year publication from Romania has the bone cut marks, which were dated by uranium lead to more than 1.95 million. It's still questionable, because we don't have lithics, we don't have human fossils, so it's still under discussion, but somehow supports also kind of our hypothesis that they came through the Danube, and then something older or around this age, like Korolevo, that the hominids were in Europe. So future perspectives, what could be next? I think that the big thing is I am calling it archaeology of archives, because we have 26 years of archaeological excavations left, a lot of documentation. Vitalii is digging in archives. Everything is written on typewriter, handmade plans, and so on. There are thousands of papers. Most of things are unpublished, so the next big thing will be to go back there and to start investigate, to do the archives. We found out recently that there was excavation 10, which was before excavation 13. We have some layer 7, even materialytics, some documentation. So we need to put back and publish it, because there is a lot of interesting things. And Vitalii did the first effort of kind of quantification, and in the museum there is around 93,000, more than 93,000 artifacts are stored, and we estimate that only around 20 to 25% are studied. So there is a huge potential to really we, like archaeologists, we like going to the field to dig and to find new stuff, new artifacts, but there is a lot of stuff in the storage and in museums which is still not published and not investigated, especially now with new methods, 3D GM and so on. You can scan them, you can put into the database, you put open to the online, you can start comparing. And Korolevo is unique site, because it's kind of like time capsule of the history from 1.4 million up to 20,000, 30,000. So then we have several layers. We know they were coming. We know the climate because we have a pollen records. So we can just start to reconstruct the whole kind of story, and also put together maybe with some genetic stuff. We can also study the cultural connections with lithic technologies. We have these links with the Middle East, Near East, some unique, some links with Asia. So we can start building up this kind of migration dispersal story. So this is something which will come, but also we would like to come back, do the excavations there, do the especially Korolevo 2 has 6 meters of profile, which all sediments which were not studied, not excavated. So this is huge potential. There are some other cool sites in the area which needs attention. And with Vitalii, we are working on a publication which will publish the unpublished and unstudied data from excavation 13 and 10 and sondage 26, that we have complete data about these oldest layers. We have even some new lithics from these oldest layers. So this Vitalii is working on a book for Korolevo 2 as well. So yeah, a lot of stuff, but also very important will be to come back to restart the work and also to protect. So my last slide is the acknowledgement for this project of dating of Korolevo site. So it was done by 4 institutes of Czech Academy of Sciences, my colleagues Jan Kameník Kučera, then Vitalii Usik, then John Jansen from Institute of Geophysics, then Vitalii from Ukraine, also the Natasha Gerasimenko from Taras Shevchenko University, then from Rosendorf, Konstantin Stübner, Johannes Lacher, Georg Rugel, and the whole team, which DREAMS team, which serves AMS. Then we had Aarhus University, Matknus, and František Veselovský from Czech Geological Survey, Andy Harris, which did comment of palomagnetism from Latrobe, and Lotta Jolamela, which she did calculation of the PPNI. And then funding was done by Ramses, which was funding main project on AMS in Prague, which we built, and we did some like pilot projects, and Korolevo was one of them. But also big thanks goes to Radiate Horizon 2020 project, which we used very extensively for beam time funding, also for guest researchers stay for processing of the samples and also for measurement. So this was unique opportunity that we were able to access the infrastructure, which was still not available in Czech. So we used German infrastructure using this Radiate project. So thank you, and I would like to dedicate this presentation to all these archaeologists and workers and anonymous people, which they were 26 years excavating the Korolevo, and without their work, it would be impossible to have these results what we have now. Thank you.